Okay, for problem 22 and 23, we're asked to circle the larger number. We can do this from scientific notation, but I think it's safer to write them out in standard notation and compare them that way. So we have 1.25 times 10 to the positive 6. That tells me that's a large number, so I need to move my decimal to the right 6 places. 1, 2, 3, 4, 5, 6. Put zeros in the empty spaces, and so that's 1,250,000, 1,250,000. This number 3.5, again we're multiplying by 10 to a positive exponent, so I know that's a large number. I need to move my decimal to the right 1, 2, 3, 4, 5 places, and that is 350,000. So the larger number is 1.25 times 10 to the 6th power. We'll do this the same way, but this time we have negative exponents, so we know we're dealing with small numbers. 4.9 times 10 to the minus 4, so I'm going to move my decimal to the left 1, 2, 3, 4 places. So this is 0.00049. And this one also is a small number, times 10 to the minus 2, 1.2. I need to move my decimal to the left 1, 2 places. I'm going to write it below this one, 0.012, and add some zeros so that I can compare them. And just looking at the hundreds place, you can see that this is the larger number of the two. 24. 1 second is approximately 0.0000115 of a day. Which expression represents this number in scientific notation? So let me write that number down below. 0.12340 zeros, 1157. This is a very small number relative to 1, so I know I'm going to have a negative exponent, which right away lets me rule out C and D. I'm going to move my decimal to give me a number between 1 and 10, so I need to move it 1, 2, 3, 4, 5 places. 1.157 times 10 to the negative 5, which is answer choice B. 25. The distance from Earth to Venus is approximately 4.184, 4 and 184 thousandths times 10 to the 7th kilometers. How would this distance be expressed in standard notation? The positive 7 here tells me that this is a large number, which isn't surprising since we're talking about the distance from Earth to Venus. So 4.184, I need to move that decimal to the right 7 places. 1, 2, 3, 4, 5, 6, 7. Put zeros in these empty spaces. 4, 1, 8, 4, and 4 zeros. So that's 41,840,000 kilometers. Answer choice B. 26 through 28. Each square root is between two integers. Name the integers and explain your answer. Well, you have to think of a perfect square that's close to this square root. So the first one that I think of is square root of 49, which equals 7, because 7 squared equals 49. Square root of 52 is a little bit larger than that, so the next perfect square would be 8 squared, which is 64. Square root of 52 is between square root of 49 and square root of 64, so it's between the integers 7 and 8. Square root of 90 is close to square root of 100, which is 10, because 10 squared equals 100, but it's a little less than that. So the next perfect square as I move down would be 9 squared is 81, so square root of 81. Square root of 90 is between square root of 81 and square root of 100, so it's between the integers 9 and 10. 28. I have this one memorized. 400 is 20. Now let's just do 19 squared to make sure we're not overshooting it here. That's 81, carry the 8. 1 times 9 is 9, plus 8 is 17. And then I'm multiplying by 10 here, so I need to start with a 0. 9 times 1 is 9, 1 times 1 is 1. This is 361. So square root of 361 equals 19. And you can see that square root of 375 would go in between square root of 361 and square root of 400. So it's between the integers 19 and 20. Okay, hang on 1 second. Nope, there's more. Okay, that does it for this video. I'll pick up the review with problem 29 in the next video.